Hi everyone. In this video I'm gonna talk about basic principles of electronics. I will start with what is the voltage, what is the ampere, current flow and such kinda. It's my first video. It's start with basic principles and that video series will go more detailed, more advanced in electronics. So I will start what is the current instead of what is the voltage, because if you understand what is the voltage, then you will understand voltage more easier. So what is current? If we connect battery like that with a wire with plus terminal to negative terminal, if we connect with wire, and if I look that point, that cross section here, I zoom in here. So what is electron passing like that, electrons. So in here, electron passing through cable. So current is how many electron passing, or how many charge passing through the wire per unit time. But we are in volt, so in SI units it's ampere. So if one clump passing in 1 second, it called as 1 ampere. So current in general, current is how many charged particles passing in a unit time. If one clump passed through that cross section in 1 second, one clump of charge passing through that wire in 1 second, it is 1 ampere. So we know 1 ampere is 1 coulomb per 1 second, 1 amp, or ampere, amp shortly. So we can calculate. Also we know one single electron, one particle, that small single electron is charged that number, 1.602 multiplied by 10 times power 19. So if we put that, it is single charge of 1 electron. So if we put in equation 1 amp, we must divide, because we will find how many particle, how many single electron atom passing through if current is 1 amp. How many passing? If you put that calculation, if you put that charge of electron in equation, we are finding 6.24 multiplied by 10 power 18. So the number is here. I typed here. So can you read? I can't read. Billion times of trillions, millions time of trillions, millions, like that. In 1 second, if such amount of electron quantity passing in 1 second, it creates 1 ampere current. In this drawing, I'm going to explain why the minus sign in how many atoms when we described. So if you, let us say we connect same battery here, it's 1.5 volt. the real electrons, here is electron rich region, a rich region, here is a poor side or region. Electrons coming from rich side, and they are passing through that side, and they are connected, they are coming to here poor side, and they are neutralizing battery. But for calculations they think like that real particle electrons flow from minus to plus side, but conventional current flow from positive to negative side. All calculations, all symbols, all shows, all current diagrams, when you are calculating, you must use conventional current flow. Let you know that just you know in your mind electron flow from minus to plus, but when you are calculating your direction, always think from current flow, conventional current flow from plus to minus, just like that. So in this given example, electrons passing through that cable, wire, conductor. So question is, if 4 amps passing through in 5 seconds, how many electrons passed totally in 5 seconds, how many electrons passed through that cross section of wire? So our formula is here. I'm putting 4 ampere in 5 seconds. So we need 20 coulombs totally charged. One single electron is charged that number, one single. So if I divide total amount charge to this charge, I will find how many pieces, how many really, 1, 2, 3, 4, how many pieces electron passing through that cross section. So it's again so large number, of course, 1.24 multiplied by 10 power 20. So if I like that, and I can put here 18, so 124, and you must add 18 times 0, that number. So what is the voltage? We saw that when we connect battery terminals with a wire, if you put lamp like this, such kind of motors, lamp, anything to wire, or just simple wire, also possible, electrons start flows and lamp is emitting light. Yes, so current flows. Current, what was the current means? If for 1 amp, I am giving the description, if 1 columns passing through 1 second, it means 1 amps. So there must be, for current, there must be something to pushing force, or I can describe like it must be that electrons must be pushed by something, pushed by energy. So that, like we can say like that push force is voltage. So if we describe like that water analogy, also keep in mind, it's so important, voltage described as like potential difference between 2 points, between not just 1 point. I can't describe what is the voltage of C, point C. I can't describe, but I can say what is the voltage, or what is the current passing through point C. I can say like that, but I can say what is the voltage of point C. To say like that, what is the point of voltage C in general means voltage difference between C and A, because A is here minus, so it means our if it's 1.5 volt battery, here is 0, here is 1.5. Oh, it's not typing. Here is 1.5 volt. So here is also 1.5 volt. So the voltage of C to our reference point 0, this point A, is 1.5. I can say like that. So let's see in water analogy. Voltage can be described as like water pressure, and I have water in here, top of the tank. So when I open that valves at same time, from A point, water hits here. Here is our ground. Water hits here. Let's say 1 meter or 1 yard, in which country I live. If you look from B, it's coming to, for example, 2 meter or 3 meter, let's say 3 meter or 3 yard, or now without any unit, 1 and 3 length. And C is more far, it's coming to 5. So what is, I can't say in voltage what is the voltage of B. I must say what is the voltage, what is the potential difference between B and I. Yes, it's so 3 minus 1, because it goes 3 meter or yard, 3, and it goes 1. So difference is 3 minus 1. So, but in generally, when we are talking, our reference point is our ground point here, ground. Level 0, let's say like that. So now I can say what is the voltage of point A in practically, but it's not correct. But when I am saying what is the voltage of A, so I mean what is the voltage of A to ground level. Yes, it went 1 meter, 1 volt. What is the B? Pressure increased 3. What is the C point? 5 volt. So what is the between, let us say, between B to C? It's, our reference is C, so it is C minus B. So 5 minus 3 is equal to 2 volt. What I am saying, if my ground is here now, my 0 level is here now, in that particular example, I am doing 5 minus 3. It's, as I said, voltage described between 2 points, not just 1 point. But when I am saying 1 point, I mean that generally, I mean that ground level 0. So also in here, B and C is equal because there is nothing changing that push force. When that coming here, it stops. Lamp is working, so pressure is changed, because that pressure or that voltage, that our energy, lamp is consumed our energy and it emits light, so it drops to 0 again. So what is the voltage between A and B? So my reference point is B and A, like that. B is if it's 1.5 volt and it's plus side, so 1.5. Oh, pen is not working. So 1.5 minus 0 is 1.5 volt. Now we will go to measure with voltmeter, multimeter or voltmeter. I will open. And we will batteries. We will put one battery, 2, 3 batteries like that. We will put and we will measure. But before of it, voltage also described as in books like that, like pressure, push force, like that. But also described as 1 volt equal to 1 joule per 1 coulomb. What does it mean? To pass that push force, pushing, if push 1 coulomb current by energy of 1 joule, it's 1 volt. Here what it means, we have 1.5 volt battery is equal to 1.5 joule to 1 coulomb. So it's pushing electrons, 1 coulomb of charge of electrons, 1 coulomb charge of electrons by 1.5 joule energy. So it's the more scientific description of volt, like that. Also there's a lot of description by electromagnetism. You can go through you can describe ampere by 2 wires pulling force, then from over there you can describe volt, like that. So let us summarize everything, short summarize before that battery experiment now we will do. So I'm gonna say current is quantity per second, like how many electrons passing or time. Here is not quantity, here is charge, but I know 1 electron how much, so quantity also I know how many electrons passing through the line. So current is about how many passes, how much quantity. Voltage is a potential difference, push force. It depends energy per quantity or per electron. I can say like that. One of them describe quantity in 1 second, like if we don't in time, like of course we must think in time, but I am talking shortly. It's describes such kind the quantity. It's describe energy or push force of electrons. So we will do now our experiment. So I have my multimeter and 1.5 volt battery and second one, and that lithium ion battery 3.7 volt. So let's measure. Now it's off and I am opening the DC volt don't worry about the DC volt, AC volt. If you keep my channel, if you keep watching my channel, you will understand. It's 1.6 volt. It's nice because nobody can give you just exactly 1.5 volts. Also there is measurement error. So also second one almost same. So if I connect them like that, at first what I did, I measured, it's my reference cable, but it's ground level cable. It's my which point I want to measure between them, volt A or volt B minus volt A. Volt B 0, volt B is 0, volt A is plus 1.6. If I am doing vice versa, like that, if my ground level is plus, and which point where I want to measure is that red one I am pointing now, it's minus. Look, see, it's minus. Okay, so I am not confused anymore, so I will put them together. Now look, my ground point is here. Now I don't want to measure that point, I want to measure that point. It's 1.6 plus 1.6, something 3 like that. It must be, yes, 3.22. Okay, so what if we will add that lithium ion? So my ground is in minus, on minus, and I am pointing that plus, which I want to measure that point. What is the voltage? 4.21. So it was like 3, like now it's 4. It will be like 7, between 7 and 8, I think. 3 of them. Look, I want to measure ground level here, ground, and I want to measure that point. Because I measured that point, I measured that point. There is no I showed you just now, but now I want to measure all of them. How much? Like I said, between 7 and 8. 7.4. So like that. It's voltage, it's multimeter. We already know what is current, voltage, and so on. In next video we will talk about resistance, how to connect them, and we will start the circuits.